Hey, hi, this is Govind, and today we're looking at a simple tachometer using Arduino-like board. This is based on ARM 32-bit microcontroller um, called MicroPython board, but any microcontroller board should suffice here. All we need is we need is an input pin, analog input pin, and the needed input voltages for the infrared LED and an infrared sensor. So what we have is, of course, the MicroPython board here, and we have an IR LED, infrared LED transmitter, which is hooked up to 100 ohm resistor and pulled up to 3.3 volts, and the cathode is connected to the ground here. The ground rail comes from the board where it is one of the ground pins is connected, and the infrared LED is a 940 nanometer wavelength. We have a similar 940 nanometer wavelength sensor, which is a phototransistor. The phototransistor is collector is pulled up, and the emitter is connected to a 100 kilo ohm resistor, 100k resistor, and we read the data from this from this pin of the phototransistor, and that pin is sent into an input pin, analog input pin on the board. In this case, it's called X12. That's the pin number on the board. So the way it works is, the board is powered on right now, and when there is nothing blocking between the transmitter and the receiver, you will sense a voltage close to about 3.3 volts. That depends on the resistor values. The board itself sends 3.3 volts to the devices, so the maximum voltage would be 3,300 millivolts. In this case, we read sort of close to 3 volts here, and when there is an obstruction in between these two that is opaque, that'll stop the receiver from getting an IR light, and that'll bring down the voltage close to zero, the input voltage into the pin. So using that principle, we can build a small tachometer. So for this, we need a fan or a motor with a blade. So I'm using a small 5-volt fan. Cooling fan is supposed to be for a Raspberry Pi 4 board. I'm using the same fan which we can measure the RPM of. So I'm just going to slide this fan in here like this, and then make sure it's fully seated correctly, so we can see that the LED and the IR sensor the blade covers both of them cleanly. Let's just reset the board now, and then we'll take a look at the code. It's pretty simple. We just set up the pins, and then we set up the we set up an external interrupt here on that pin. The pin is defined here as the pin X12 here, which we pass here as one of the variables parameters. And then once every time there is an IRQ falling on that pin, when it goes from high to low, it just triggers an IRQ interrupt, and then we just call this function measure, where we just count up. So that means that every time there's a blade that's blocking the sensor, we get an interrupt count, we increment by 1. So every increment of 1 means that there is a blade that passed through between the sensor and the LED transmitter. So we just count the number of times it passes for 2 seconds, and then we just divide it by 2 and then multiply it by 60 to get the number of the count for a minute, and then that becomes the revolutions per minute. And then of course we have to divide it by the number of blades. In this case, the small fan has 5 blades. So yeah, I had rebooted the board, and it's running here. We see that it's plotting, actually reading about 3000 RPM here, and we can just slowly try to remove this, and then the RPM should go down to 0, and that's what is happening. And then we can slide it back again, and it should start reading. The same thing. Yeah. So yeah, thanks for watching the video.